the go live button like 12 seconds too late. I'm over here like vibrating in my seat, Yuri, and Vlad's like, yes, now it's time to go grab something to drink, or let's go continue the conversation. But we are live, so this is very exciting. I get to embarrass Vlad for, I guess, 2 times in the beginning of this. Everyone welcome to Manufacturing Hub with me, Dave, this guy up here, Vlad. We are continuing to talk about the Edge ecosystem. We want to thank the folks at Siemens for sponsoring this theme. We want to thank Chris Liu last week. He was out there. He gave a bunch of really good resources. If you guys are looking for resources, talking about Edge, talking about cloud. And as we were prepping with Yuri, as you guys will hear in just a moment, Yuri's like, I've got 47 resources that we need to be sure to include. So I'm going to like put a sub theme of the Edge ecosystem as this is all the free resources everyone has always wanted from any of the Manufacturing Hub shows. So I am very excited to talk about and to go through that. First, as we do, Vlad?
Well, I was going to mention as a small note, if you're listening to this in podcast form, you will be able to find all the links we will be discussing on the website, which is manufacturinghub.live. And so there will be footnotes for this specific episode. Go ahead, Dave.
Well, one, this is amazing. This is the first time we've ever actually got Vlad to go push people to go to the show website. So this is a momentous occasion. Thank you, everyone, for joining us with that. Before we jump in, I do want to, I would tell everyone to go check out manufacturinghub.live to see the show notes and the resources and to subscribe to our newsletter. But Vlad has already graciously hit that. So let me go slightly embarrass Vlad for the second time, where we want to say hi to everyone at Solus PLC on the YouTube channel. There are a couple hundred of you guys watching us to this point. Thank you for being here. If you guys are not subscribed to Solus PLC, join the like 33,000 other subscribers. Hit the subscribe button. Go ahead and hit subscribe and follow for the Manufacturing Hub webpage and my page, and Vlad and Yuri will absolutely, you guys have his contact information on the live event, and we'll give them a chance to talk about that before. But please hit the subscribe button. Again, I have found every time we one have more subscribers and 2 people continue to download our podcast. What a strange thought, right? But no, with that, everyone, welcome to Manufacturing Hub. I am Dave. This guy up here is Vlad. And we would like to, again, welcome everyone to an Edge ecosystem theme that we have with our very special guest, Yuri Chamarelli. Yuri, thank you for being here.
Yeah, thank you, Dave. Thank you, Vlad. My pleasure.
I really appreciate you joining us today, Yuri. I'm looking forward to jumping in the conversation on Edge devices, Edge ecosystems. But before we do that, I wanted to get maybe a little bit of a background from you. I know that we've talked in the past and have met through Phoenix Contact. I want to get to understand a little bit better, how did you get into manufacturing? What was your involvement with Phoenix Contact, and how did the transition take place to AWS where you are today?
Yeah, absolutely. Thanks for the space. Love to talk about career progression. Very passionate about that. So I think my journey is it's not different from many of the cloud colleagues that I have today. I started just like you have on a manufacturing floor, helping to build, getting panels up from the scratch and getting machines connected to PLCs and HMI and its SCADA systems. And I spent quite a bit of time on the locomotive business. My first job was actually as an intern with GE, and we worked on those GE PLCs for some of the locomotives, and it was pretty cool. Got very passionate on for that back in the day, and from that ended up going back to school, and I got another major into controls engineering, and went working for Schneider Electric for a few years. Also pretty focused on automation PLCs and SCADA and programming substations and things like that. From that, I ended up working for Phoenix Contact for quite some time, close to 8 years with Phoenix, which was an awesome journey. Phoenix, as you know, makes everything from a connector to software and PLC. So I had this awesome experience on doing a little bit of everything with customers. And that, during that journey, managing PLCs and working with machine manufacturers, there was a lot of demand for how do we get connected to the cloud, right? So customers would ask that question, and over the last 5 or 6 years or so, that digital transformation, Industry 4.0 or IIoT, all those things that we hear today, they kind of were born and the specs were put in place. So I kind of learned that as it was being spec'd out and it was coming out, and by helping customers, really, I want to say that like I learned from what the customers were asking me to help them with. So at some point, so the journey that brought me to AWS was really this wheel of helping customers and really helping customers at scale, I guess. And AWS really allows me to do that. I talk to a lot of customers every day, and it's really cool to see all the use cases that they're working on. It's like you go, I have one call in the morning with some customer that is building a smart lock for a door, and in the afternoon I'm talking to some industrial customers that they are trying to monitor, I don't know, oil pumps, right? So like just this range of different use cases and applications, it's really exciting to be on this. So that's what brought me here, guys.
I'm curious, I guess, to expand a little bit on the current role. Again, maybe taking a step back, where you had a lot of involvement on the hardware and software side, are you still exposed as much to both platforms? And again, we're going to dive into a little bit into the like AWS services, because I'm curious, how they manage cloud computing and IoT devices. But are you, I guess, is there a difference, right, in the two worlds when you move into more of like a cloud solutions provider, or are you still very exposed to the hardware platforms and like the edge devices and I want to say like the hardware solutions that you would see in the manufacturing plants? I just want to, I guess, like paint a good picture for those who are looking into cloud as perhaps like their other career, or as I always, and I think I've told you this off stream, I often tell engineers that they should be learning these technologies that are, I think, only growing in applications. So could you maybe elaborate a little bit more on how the day-to-day involvement is with like software versus hardware, and what's your I guess experience has been like?
Yeah. Oh, well, I think I could yeah, I could add a little to that. So I think when in what comes to IoT, that isn't just the cloud. That will always be a device element, because it is the Internet of Things, and you do need the thing. And in my job today, and at AWS, we do dive deep into helping customers with devices, and that is because the customers, we are working from what they are building it, and a lot of times customers, they do know their devices really well. They know what they're building. They understand the engineering of those devices, right? Mm-hmm. So our job is to understand, okay, what do you need? How do we help that customer to bring that engineering, all that know-how, all that cool stuff that they make, all the business value that is on that device? How do we help them to design for that and be cloud ready and come to the cloud and bring data, bring value, and interact with their systems, and also provide value to their customers, because in most cases, customers are serving other customers of their own. So yeah, we are pretty much involved in helping customers with device software or edge software, if you will, for some customers. And AWS do have solutions for that. We have services. There are device software specific. Could mention Greengrass, FreeRTOS. So we do dive deep into microcontrollers, because part of the solutions out there, home devices, wearables, and some sensor to cloud industrial solutions are microcontrollers. Microcontrollers are not going anywhere. They are great devices, and they're actually just getting cooler and cooler and getting more technology in it. And also microprocessors, whether it's Linux-based or Windows-based or some Unix-based proprietary OS, we are touching those challenges with customers, and we're helping them to design for that too.
And if I understand correctly, AWS is, I want to say, like brand agnostic when it comes to the hardware, right? So you can provide a hook or an API, I guess, or a way to communicate from a number of different platforms. And so there's a certification. I think we talked about this a bit off stream. I guess there's a certification that an OEM could go and achieve in order to allow like their hardware be, I guess, like published as one of the reputable vendors. That's how it works.
Yeah, in fact, so one of the resource links that I sent you guys that we may be sharing here has what we call the device catalog, certified device catalog for. And what we do in this catalog, we have manufacturers of IoT. They describe what the device does, what use cases the device can address, and we guide them. Hey, you could be using these services from AWS to enable your customers to use your device, right? And those services, like when you go into the catalog, you're going to see that we have different services that those devices are compatible with, and that is also up to the OEM, to the manufacturer of the device, to select which services they want to be compatible with. And what does that do to our other customers is that now they can focus on their business, right? So, and that kind of goes across the entire industry. So they can focus on building their platform, and they don't need to think about building devices, right? So there are two types of customers out there. There are customers that have the engineering knowledge, and they really want to build, they are building the device because that's their business, is to build that device and develop their own software, and they come to work with us to connect to the cloud. But there are other customers out there that they are not in the business of building devices. Mm-hmm. They are in the business of collecting the data, or building machine learning and anomaly detection systems and business intelligence systems on top of that data. So they want to spend that time doing that. So that's what the catalog is great for, because we help those customers to save time. Just pick something that is already certified with AWS and go. And it is as agnostic as possible, because the certification process is up to the manufacturers.
And I think that's like an interesting piece, I want to say, of IoT, or like IIoT or edge in general, is that I think, having been in manufacturing for such a long time, you almost assume that it's going to go on the manufacturing floor, but I think it touches quite a wider scope. And I think you've mentioned microcontrollers, which are in some of the older PLCs. I think now it's mostly microprocessors, but like the IoT arm of AWS touches quite a bit more than just what you would imagine on the production floor. But Yuri, if we can go into, I want to say, more of the fundamentals, right? So if we want to have a definition, and I think Chris has given us a take last week, but could you maybe elaborate to us, like, IoT versus edge, and how, I guess, you see it from maybe like an AWS standpoint, but I think also the question of, if someone's trying to or looking at like edge or IoT solutions at a trade show, or maybe someone mentions it to them on whatever platform, like how do they start thinking about that and starting maybe to realize, is that the right solution or the right move for them?
Yeah. Absolutely. So yeah, that's a very broad topic, and I
Mhm.
feel like there are a lot of on what's edge, what's IoT, what's cloud, what's and the, I can I'll give you a little bit of my vision, my personal vision on what I see customers doing it. Uh, and at least at AWS, the way we work, we look at what the customer needs, and usually, um, in most cases, that separation of this is an IIoT platform or an IoT platform, this is edge, this is cloud, that is driven by the customer themselves. Because customers, companies, they have different interpretations of that concepts. And the way we operate, the way we work is by really going with the customer and kind of following their needs. So, and now we also can look at the other side of the story, which is uh, IoT is Internet of Things. So you have a thing and you have the internet, and you can think that that internet now is the cloud. Um, Even though there are systems and IoT platforms that are not connected to the cloud, you could have a proprietary, uh, a private network that is IoT and it's not even connected to the cloud, right? And that is also an application use case. But let's look to the most common type of IoT, which is you have the thing, you have the cloud. So when you look at the cloud, you think of the concept of cloud computing. Cloud computing is the act of using computing on demand, and you pay as you go, right? And that's what AWS offer to customers is we have cloud services, we have computing, and that computing is divided in many different types of services and solutions. And customers, they come with us and they pay as they go and they use as they need. Uh, in the other side, the thing is anywhere but in the cloud. So when you put those two things together, that's what I see, what we interpret as IIoT or IoT. IIoT if it's in the industrial floor, IoT if it's a commercial wearable or a home device. Now, when you ask me to kind of define a little bit of what I think it's, and you asked me about edge, right?
Mhm.
Um, so that is a very application and customer driven interpretation, because what's edge for one customer, it's not edge for other customer. What's edge for a manufacturing floor, it's not edge for a Roomba cleaning device on your home. So that interpretation is really connected to the application itself. Uh, so it's hard to generalize he's the edge, and I try not to do that. I try to, the way we work here, we really look at what the customer is doing it, and we ask them, hey, where you think your edge is and how are you going to make everything secure. uh, and we take that security first approach in between edge and cloud. So
And it's certainly, I would say, like a tough challenge, when you don't have a concrete definition for the industry. I think it certainly is, I want to say, application specific, in my experience as well. And I think as a community, we're trying to define it a little bit better, but I certainly don't think that we're there yet. We have a question though from Ira, and I think it's an interesting one because it relates to this. I want to say segment as well. So he's asking Yuri, in your current role, are you dealing more with device manufacturers or end users with digital solutions? And I think, to expand that on that a little bit, I think there's a huge maybe like education component as well, right? Like when you're trying to talk these customers through these solutions, trying to understand, and I want to say like the perspective of the end user versus like an OEM versus maybe like a systems integrator, because I think they all obviously play together but have slightly different ideas? Like, what are, I guess, like, what is your current role dealing with, and what are your thoughts around that educational, I want to say, component as well?
Yeah, great question from Ira, of course. Hope he's doing well. The I think like when we look at and the IIoT, the industrial digital transformation scenario is really good to kind of capture that. And then we think about, if you look at really big companies, they are industrial in nature. They have been building their infrastructure for over 25 years, most of them, right? And then when you look at that infrastructure, it's a mix of technologies from many eras. And it's really hard. It's very challenging to build something that can just be homogeneous and address the challenges of all those slices of technologies that need to work together. And we see customers having quite a bit of a challenge trying to create that type of platform. It is hard. It is challenging. There is no easy path and solution for that. It takes a lot of work, a lot of planning, and a lot of will to work with different companies to bring something together. Then here from AWS, and now answering the question, what I see the most and what I've been working with the most, it's really to help customers to find this components to build their platform or their final solution. And when you look at that from an IIoT lens, it's really, you need the devices to collect the data. Devices can be coming from different component manufacturers, PLCs and historians and industrial PCs and sensor to cloud type of boxes. And it's a mix of that that takes to build a smart manufacturing connected to the cloud. Then you need to understand the journey of that data. You need to understand the challenges of what data needs to go to the cloud, how the data goes to the cloud, how fast the data goes to the cloud, and then what you do with the data in the cloud. And when it gets to that point, we also work with finding partners, and AWS works really hard to have partners that can serve our customers the best. And so we help these customers to look at the partner network and see which partner has a solution that fits their requirements. And by experience, Vlad, what I can tell you that I have not seen a really big company build an entire IIoT platform with a single partner just yet. It takes more than one partner. It takes more than one component manufacturer, and it takes many teams within that company coming together to get that to happening. So I think the biggest challenge is really building that trust relationship between partners, us, AWS, and also the manufacturers themselves. So my job is really to be that trust advisor on, hey, let's look into this. This works with that. We here at AWS, we try to be customer obsessed. So we are customer obsessed. So we are really looking into, okay, let's look at what's the best for that requirement. If this partner doesn't fit the requirement, if it doesn't work, it doesn't matter. We need to look into other options. We need to find what's gonna drive you to completion and to the business outcome, right? So I think that's where I spend most of my time, making those connections, helping customers to understand what data has value and how they're going to get that data to AWS cloud, and then what they're going to do with the data. I think the device side of things usually also turns to split into many devices to accomplish something.
I think that makes a lot of sense. Dave, I want you to jump into the conversation as well, because I know you have a lot of experience in this domain, and I'm sure that I guess the comment I want to make, I like the fact that you mentioned that the various, it's starting with the customer first and finding the right platform S with, plural for them, because I think in a lot of projects that I've at least like seen is you try and standardize, and that almost like hinders what the final deliverable is. And I'm sure both of you have seen that many times, but Dave, your thoughts, and maybe next question for Yuri as well.
No, I think all those are good. And I think Ira's question actually set up something that I've been wondering for the last couple of minutes. So Yuri, when an end user comes to you and says, hey, I need help figuring out this solution, right? Do they typically have hardware and edge devices that they've been using, and they're looking for an AWS piece of software or part of the platform in order to get the most out of it? Or are they looking at like AWS Greengrass and they're like, Yuri, okay, what edge devices do I need to get the most out of your services? Which way or which ways does that typically go?
Cool. Well, we see customers here. We help customers on both of those stages, and we see that like a little bit of a cloud adoption stage. And so we have here at AWS, what we have this working backwards process, right? And in the working backwards process, the way we look at it is, okay, we're trying to understand where the customer is at. Sometimes customers already worked within the OT and they already have that data somewhere aggregated. They're already collecting all the data they need to collect. I'll give you an example. They already have a historian that is OPC UA capable. Not going to mention names, but you guys know some of them. And that data is already organized in a way that can be consumed by cloud. So in that case, the work that has to be done is really to create that pipeline in between the premise and the cloud in a secure way, economic way, reliable way. And we take the 6 pillar approaches for that. And we can do that as AWS and help the customer to build themselves. We can bring a partner in that can help them to build a partner solution as well. There are other stages that we are working still on defining how those edge devices need to be built.
I think we lost Yuri for just a moment, but
oh, there we are.
Lost you for just a moment, Yuri.
So what was the last thing you said?
There are sometimes that you guys are working with customers to define edge devices that they need for their applications.
So as you define the edge devices, that's where we apply the AWS device catalog. So we go to that catalog and we work with customers. Hey, here are the requirements for your data collection or your data processing at the edge. Let's look at which devices can fulfill that requirement. So we look at environmental. So that is a very OT engineering type of work that my background kind of helps me to do very well. So I can actually look at. Did you guys lose me again?
Just for a second, you said I can look at.
So yeah, so I can look at. So with my background, I can really help customers to actually look into hardware, environmental specs, and processing capability, and all that is necessary to run things at the edge as well and collect data.
I like that. As a follow-up, Yuri, is there kind of a solution that you have found works best, kind of creating that pipeline from a historian, and then you don't have to worry about the particular edge devices? Or are you guys dealing a lot with like we've got IPCs that are mirroring a whole bunch of machine data, and those are just directly connected to AWS service.
Well, and sorry, my connection is still spotty there.
We can hear you.
That's okay.
We lost the camera feed for just a moment. Go ahead, Dave.
Yeah, I kind of took my camera feed down. Sorry about
that. That's okay. Let me go ahead. Did you hear the question, Yuri?
I did catch the question. Okay. So, well, as far as solution to, so when you look at the edge, right, and maybe you gave me a little opening to talk about this, this methodology that we apply at AWS and we use with customers that we call the 3 laws. And I really like it. I think it's a really cool concept. Is when you're doing something at the edge, especially with edge devices and industrial data, that applies really well. You look at these 3 laws. The first one is the law of physics. So the law of physics is you need to send data somewhere, you need to process the data, and you need a response. But if that needs to be too fast, faster than the speed of the light, which we use in communications can do, it means that you cannot send that data to the cloud and get it back in a timely response that is okay for your application, right? So when it comes to that, which is like when you think about PLCs, PLCs are real time because they are fast. You need, it needs to be real time. It needs to be real time, can't fail. So that's why everything is happening at the edge. So if you have something that needs to be responsive and it cannot rely on cloud connectivity at any moment, it's a good reason to keep that processing at the edge. The second law is the law of the land. And the law of the land is, it really comes into sovereignty of data. For some reason, that data cannot leave the edge. Let's say that there is some intellectual property or some regulation within that manufacturing facility that does not allow that data to leave the edge. It cannot be sent to the cloud. So you need to be able to utilize that data at the edge somehow. And finally, the law of economics, sending data to the cloud, it's not free. It has a cost, and the more you send and the faster you do that, the more expensive it becomes. So what we help customers a lot with, especially in the manufacturing and industrial realm, is to define what data matters and how fast you want to see that data and collect the data to the cloud, and make sure that is optimized, because you don't want to spend more money than you need on that communication. So with that said, when we take into consideration those 3 laws, the edge device is never the same, right? Because the more processing you bring to the edge, a more powerful edge device you need to apply. So it comes into application, right? I hope that answers your question, but it was I took a long route to get there.
No, I think it's good. I know Vlad has 1,000 other questions, but before that, I want to drill into the particular law of physics that you had mentioned, Jerry. Drill into the particular law of physics about how some things cannot be done on the cloud, right? Maybe it doesn't economically make sense, or things need to be computed at the edge as opposed to in the cloud. I think that's a different take and a different topic than any of the conversations we've had about IoT or IIoT in the past. Can you kind of can you talk a little bit more about that, or perhaps you have an example of you guys have gone through this process and decided that computing on the edge makes more sense?
I do have a great example. So we worked with many customers in a similar application, but I can't give an example of a customer that I worked on. And their application was to be able to use CV. CV is a specific Python-based type of image analysis. So you can actually look at JPEG or PNG files and be able to detect anomalies on that image. So what this customer wanted to be able to do was to have a camera in their manufacturing line that would be able to tell if the finished part which was an electronic component had any anomalies, like a LED out of place, or like a resistor or any component out of place, or the board was damaged anyway, right? So when you think about that, now we're dealing with two things. I need to take pictures of that part. I need to run compute on top of the picture so I can understand where the anomaly is, and then I need to take an action after I detect the anomaly, and that has to happen within a few seconds, because those parts are coming out of the manufacturing line really fast, right? So if I was relying on cloud to do that, I would have to take a picture, compress, put in a HTTP communication, or have some type of fast protocol with the cloud, send the picture to the cloud, have the cloud running computing, and send the response back to the edge. That is just no way that I know that you can do this within seconds. It's just you have delays, you may have connectivity problems, right? So what is the solution over there? Well, use machine learning and AI in the cloud. You train a model, you teach a model how to detect those anomalies. And there are many services in AWS that can help you with that. And then you deploy that model, the intelligence model, to an edge device. So now you can actually look at those pictures at the edge. So you can take a picture, you can look at it, and you can have a response from the model, from the detection model, within in less than a second. And that also influences the edge device quite a bit. As you can think, you're going to need a edge device that can be highly efficient on graphical processing. So we're talking about a GPU, a graphic processing unit. So that would be a edge device that also has a GPU. It can't just be any device. So yeah, that's a great example of why you should keep it edge.
Dave, did you have a follow-up? Because I
love
have a few questions on that example.
Please go ahead, Vlad. I feel like I've got to ask the last 5 really good questions, so you should get an opportunity as well.
So Yuri, I guess just to elaborate, on that example, and I want to say the general edge or IoT architecture, and I think also segue a little bit into understanding AWS a little bit better, because I think, and I'm speaking for myself, I was not aware that you can deploy certain AWS services on an edge device, right? So in that example that you've mentioned, it's possible to not only obviously compute at the cloud level, but it's also possible to bring some computing from AWS onto an edge device and process the images or do any kinds of other computations. Could you maybe walk us through that architecture and what's possible, and where's the, I want to say the delineation between the edge hardware and what AWS offers?
Yeah. So in this case, for what we the way we address that, and there are many ways you can build such application, but we do use Greengrass for this one. The customer use Greengrass for that one, and within Greengrass, we can, which has a runtime of its own. So basically, if you have a Linux operating system or Windows operating system, you can have that runtime as a guest application for that operating system. And on top of that runtime, we can deploy components. We call them components, and components can be any type of computerized process. It could be a Python script running CV. It could be a Java script running a security audit. It could be a Python script running a OPC UA server or a OPC UA client collecting OPC UA data. It could be an MQTT broker. So components can be a variety of things. And we do offer some components for visual inspection. That's called Lookout for Vision. And that was the one that was applying in this example that I gave you guys. In that case, we already have a runtime, a component that runs a Python CV intelligence model, and you train the model in the cloud. So you capture it. So in this case, you can capture a bunch of pictures of your parts. You can train the model with as little as 40 pictures, and you just need to manually tell the model that, hey, this is a good picture. This is a good picture about 40 times. And after you tell the model all the types of good, how the part should look like, the AI and the ML knows what's not good. Mm-hmm. And then that is compiled as a Python CV detection model. And then you can run that with Greengrass at the edge. And that's how AWS address that challenge as a service. The customers go on building other proprietary solutions to do so. So do customers. So do partners, sorry. So there are partners, we have partners that can provide customers with cameras and detection services and applications running at the edge as well.
Interesting. So I think it also solves, I guess, the challenge, and I know we haven't talked about this a little bit, but across different industries, right? Your edge devices may not always have that connection. And I think like we've mentioned some of the reasons, which could be, like compliance or regulation, but ultimately it could be just because they're so remote that they don't necessarily have a constant link to the cloud, right? So what you're telling us is that you can do a lot of your processing even with like AWS services at the edge without necessarily having that link to the cloud in permanence, correct?
Yeah, and I think we did talk about that the other day. Mm-hmm. We cannot, I mean, when it comes to IoT, you can't design a platform. I'm not going to say you can't, but you should not. It's the best recommendation that you do not design an IoT platform expecting that your edge device is going to be always connected, because that is not a reality. Mm-hmm. Connectivity loss happens, things happening. You have a Roomba cleaning your house, there's a good chance your kid's gonna kick off the staircase. I don't know, things can happen. So you gotta be, true case. You gotta be ready that, you need to be able to react to the environment. And good edge software allows you to do that. It's the classic case that in industrial that happens quite a bit, because you may have the greatest network that you can possibly build with Cat7 Ethernet cables and all the magnetic suppression that you can actually acquire. But if one single loop of the electromagnetic protection is out of place and you have one surge, that could take down one of your routers, and that's enough to take down your cloud connection. So you need to be able to react to that.
No, absolutely.
I love that.
Go ahead, Dave.
I was going to say, I love that. And I think that that's a really good segue to thank our sponsors. And then we'll come back and ask you some more questions. But as I mentioned, we want to thank Siemens for sponsoring the Edge ecosystem and allowing us to have these awesome conversations like Chris last week and Yuri this week. Data is being generated continuously on your shop floor. Are you benefiting from it? Or would you like a faster and easier way of analyzing your data so you can acquire valuable insights? Siemens Industrial Edge will help you get the most out of your production data and optimize your machine and plant availability and performance. It also gives machine builders the opportunity to develop new service strategies and business models. Industrial Edge represents an open, ready-to-use edge computing platform consisting of edge devices, edge apps, edge connectivity, and an application and device management infrastructure. It makes it easier to collect and analyze data from industrial resources, enables a faster and more reliable rollout of apps on the shop floor, and provides central management for devices and apps with maximum scalability. And there's no need to intervene with the existing automation system, which is, I think, one of the major benefits on my side. If you guys want to find out more, you guys can go take a look at the Siemens Industrial Edge, and then we will, of course, go ahead and drop links into the chat if you want to see that again. Again, it was like during September, and this conversation about the edge ecosystem. Vlad, back to you.
Yuri, we have a question in the chat, and I think we've talked a little bit about this, but Robert is asking if the platform is designed so edge devices are capable to buffer the data. I want to, I guess, like really quickly address this because I think it's one of the use cases. And again, I think if you have maybe technical questions for Yuri after the conversation that we're having today, you can certainly reach out and he'll be able to elaborate on, like very specific application, maybe centric use cases. But like I guess the short answer is that it's not necessarily designed for that specifically, but it's more than capable to accomplish the task of like buffering the data, right? I think it's a very common kind of requirement in manufacturing. I think all of us have seen, again, like the loss of connectivity, but it's not necessarily designed for that one item, but it is something that it's more than capable of.
Yeah, data buffering is that we could talk about data buffering for 2 hours over here non-stop.
Yeah.
It's such a like common use case all throughout all the industries, from your Ring camera and your Alexa to all the way to your locomotive, right? And there are many ways you can do it. There are many ways you can address it. You can look at how the cloud can help you to do that, and you can look how your device software can help to do that. In case of like when you look to manufacturing, and those staying within manufacturing as a use case, it's very common that if you're acquiring big chunks of data from many assets, right? And that's the case with OPC UA or even MQTT. Or even industrial protocols that are being converted from an industrial type of protocol to a internet capable protocol such as a TTPS. You're receiving a lot of data, so it is best practices that you prepare your device software to buffer that data. Now, how much data you buffer, that is application specific, right?
Yeah.
I give you an example of one of the services that we offer right now. It's called AWS IoT Sitewise, and we have built that from customer requests. So we work backwards from what customers were asking us, and we defined that we should be able to support up to 30 days of buffering. So if you build with AWS IoT Sitewise in your device software, which is also Greengrass, you're going to be able to buffer up to 30 days of OPC UA data. And in that case, again, and then you got to think about your edge device again, because now you're buffering 30 days of data. You got to consider how much data you're collecting, and you got to consider you have disk space to buffer all the data, right? So again, we're talking about how well you should be designing your edge devices and how you should consider that. But yeah.
And I think like your network, I mean, sorry, not the network, but the 3 laws that you've described earlier on, I think is a good starting point, because I think, again, maybe to elaborate to some of the, I want to say like greener or younger engineers who are just starting to tackle some of these challenges, but we're having a conversation, so we're sometimes oversimplifying what these aspects really are for a specific application, right? Because we can, as you said, spend so much time about data buffering, we can talk a lot of time about, the cost of going to like an edge solution, the cloud, because there's a lot of, I think, like challenges that need to be figured out for that specific application before you can give a concrete answer, right? And so I get a lot of these questions myself, and so I think it's important to understand that in even a 1 hour long conversation, it's very difficult to cover all those aspects. So I think it's going to be up to you to reach out to like an expert such as Yuri or any other, I want to say, like local maybe distributor who's familiar with the system, who truly like understands the application and spends the time to kind of learn what the requirements are before giving a technical answer to those questions. Dave?
And I was going to say, if I may, kind of to answer the question, I guess in my experience, I have found that the more critical the machine is, the more kind of high dollar values run through a machine, and the higher the probability of internet going out means that you're going to want to have edge devices or edge gateways or something there to be able to store and capture that. So I've worked with facilities that they had 2 buildings down the block, but they lost connectivity like 4 times a month, like literally once a week. They'd lose connectivity of the intranet. So we had to put servers in both buildings, and then we had to be able to go back up and make sure that the data was correct on those. I've worked with facilities that while they were redoing parking lots, people cut through the fiber optic networks and power between buildings. And if we didn't have edge devices and gateways in the building or on the specific machines, they would have been down for weeks, right? Tens or hundreds of millions of dollars of downtime. And I've worked with like far out like oil and gas or water wastewater facilities that the question is, hey, can we back this up in the cloud, or where can we put a second, backup server for all of this? And it's like, we have really poor internet and it's bounced around like 3 satellite dishes, and we have connectivity like 40% of the time, and when we have it, it's always really bad through radio and or cell phone. And so there are some places that edge is basically the only solution, right? That there are certainly opportunities like Yuri was talking about, putting trained models on the particular specific location, but the more critical the infrastructure, be it building or machine, is, and the higher probability of disruptions, I find it becomes a very easy use case to spend the money to put edge devices and edge solutions within those individually.
Yeah, that's a great example there.
Yuri, we talked. Go ahead.
I'm good.
I was gonna ask. So we had an example of like machine vision of one interesting example for edge, and I think that's I guess I had not thought that there was capability to do graphic processing. So I think that's a real interesting use case. Are there more interesting, I want to say, like applications that are maybe outside of the norm? Are you doing things with like robotics? Are there interesting things in like automotive? Again, obviously within the confines of what you're able to share.
Yeah. So, one thing that we've been seeing quite a bit right now is this growing interest for a fusion in between, especially in manufacturing, this fusion in between sensor monitoring and image monitoring. And it goes in 2 ways. You can use the example that I gave you guys in a little bit about taking pictures and looking at anomalies within that image, or you can look at live stream as well. And we have a really cool solution for that called Panorama. And what customers are doing right now, they are looking at ways to interact with the data by looking at when the anomalies happen within the picture or the live stream. And when that anomaly is detected as within the images or live feed, they go and look at the timestamp, and we can look at how the sensors of a specific machine or location, how the environmental data was behaving at that exactly moment. So by merging that type of data, you can actually start gaining insights on, hey, my final product has an anomaly, and according to my data at that moment in time, the vibration of my machine was at this height. And then you can rule that, you can deem that as an anomalous vibration. And now you can do what? You can set an alarm based on behavior, that when your machine is starting going towards that vibration or that humidity or that combination of temperature and vibration, and it's a multi-metric alarm. Then you have an alarm that may stop the machine, may get someone to, it can be an alert, it can be a completely stop, a halt. If you're looking at very high-end manufacturing where processors are actually using gold, you may want to stop that before you use your gold. But yeah, that's really cool. It's getting we getting to this level that customers are really learning how to use their data and gaining insights from the data, and then they are setting alarms that historically, when you look to industrial automation and manufacturing, alarms are basically, he's my threshold, and if it goes up or down that threshold, I set an alarm up, right? And it used to be one metric. Now it's this multi-metric type of alarm, and we have really cool service to help with that. But that's what customers are going into right now. So it's a multi detection, if you will. So many things can set an alarm off now.
That's really interesting. So I guess like my question is how difficult is it to set up one of these like live streams? And I guess so, just so I understand that I like processing this correctly. Let's say if you have a machine that, let's say like a simple box former, right, that creates boxes and there's outputs of boxes, you can set up a live feed at the output, and then let's say a box is misshaped or not closed correctly, it rejects that box, and then your model would self-train itself on saying, like, that was a reject, so I should be monitoring, or I should be, I guess, like logging some of the metrics of that machine. Like, how does that, I guess, like I've never seen like using a live feed for like training your model, but that's really cool.
Yeah, so it's all about training the model, and then after, like, it's not usual to see a application where you're detecting anomalies and reacting to those anomalies at the same. I'm sorry, you're training your model and creating anomaly detection and applying them at the same time. That doesn't happen in one cycle. So sure. Usually you're training your model. You're training your models with what we call code data, which is historical data and archive and such. So in that case, you can look at pictures, you can look at live streams, and you can trace them. You can connect them by using timestamp. It's a very simple association. So, and then you let the machine learning do its learning, and we have several ways to do that, and ways we can help customers to do. And again, I'm not, and by any means, I'm not claiming AWS is the absolute specialist on training models. A lot of times customers, they are fantastic, and they know how to train their models. They know what they need to do. They come to us for guidance on how to apply in AWS. We can help customers that don't, but we also help customers that know what they're doing with their models, right? So then once you train it, you bring the model to your detection flow, right? Then detect anomaly detection model, and that can be part of your alarms. You can even, some customers take more simplistic approaches on, they use detection models to look at the data and find those anomaly thresholds. This is a bad vibration, this is a bad temperature, and my anomaly detection is telling me that this is a bad pressure. Now they grab those set values and they go back to their process and they set the values manually, or they have some sort of loop that is resetting those attributes and values to react, right? So
I have many more questions on that topic, but I feel like I'm gonna take us on a tangent into like AI and ML a little bit. So I want to maybe give Dave an opportunity to ask a few things, and I know that Yuri, we have a couple of resources as we mentioned at the beginning that I think we should also dive into. Dave, what are your thoughts? And do you have a question?
Yeah, absolutely. I think this has been great. I think that this would be a great time for Yuri to talk about some of those resources. I know we have a list and we'll go ahead and populate them in the chat, but Yuri, can you walk through some of the resources that are really good if people want to learn more about kind of any and all of this?
yeah, I can with pleasure. So one of the resources that we here at AWS, we really use quite a bit to help customers with. It's called AWS Well Architected. And AWS Well Architected, it's about architecting in a way that you can get the best outcome for your business out of building AWS. And we have this methodology that has six pillars, and those pillars and one of those links has the link to the white paper. Those pillars are at operational excellency. We have security. We also talk about reliability and availability. And then there is performance, efficiency, cost optimization, and now we talk about sustainability as well. It's interesting talking about customers and going through this process that we call the well-architected review. And we do that in the IoT domain as well. So we take those 6 pillars and we apply to your IoT platform. So we're gonna look at your device software and is it available? Is it secure? Is it operational excellent? And you always are trying to balance the pillars because you always take the security first approach, right? Let's make it secure as possible and work backwards from that. But then we want to make something highly available. Well, something that is highly available will push your cost a little up, right? So you need to balance, okay, where you want to be in cost, what can you compromise in availability? So we do those exercises with customers on find balance, right, for their systems until we can have some synergy across all the pillars and the customers can find the business outcome. So if you are an IoT developer or a cloud developer or a OT developer who is trying to get into IoT, it's a great reading for you. It will kind of show you how cloud computing has so many sides to it and so many things you can consider. So it will help you to kind of like look for the right resources to learn that. And that's one of the resources I had there. I had another link as well. Did I? Can you confirm?
There's your book, and then you also have the blog article.
Yeah, absolutely. So let me talk about the blog first. So that is a blog by a colleague of mine, Shanna, and it's a great overview of the stages of developing an IoT platform. And it's an interesting reading. It's not long. It probably will take you 15-20 minutes to read that. But Shanna goes over the aspects of designing a device that is meant to connect to cloud. And he compares those designing stages with the OSI model. And when you think about internet and connectivity, it's all about the OSI model. We have all those layers, application layer, and all the way to the physical layer. And you have considerations in each layer and those considerations are different. And his approach is, his methodology is really cool because it gives you a framework to have those considerations in an organized manner. So you don't overlap, you don't get overwhelmed, and it's great for newcomers to IoT because it gives you a good overview of everything that an IoT developer needs to consider end to end, right? It's not just about developing an IoT device. You need to develop the platform that is going to consume the IoT device data. It's never just about connecting data. There's always value on top of the data. So that's a great blog. I really like the way Shona wrote that, and I recommend. Finally, the book. So that's one of my favorite books. How We Got You Now, 6 Inventions that Changed the World. And I think that book is interesting for anybody in technology, not just IoT. And it breaks down history. It's a history book. It's not really a techie book, but it shows you how we don't think about some of those inventions, how significant they are to our lives today. And there's a really cool, I don't want to spoil the book, but there's a really cool story on glass. Glass is one of those 6 inventions that changed the world. And you think about glass, and I just challenge all the listeners right now. I want you to, for the next 10 seconds, trying to imagine your life without glass. The glass in windows, TV, the way you look at the mirror every day, the iPhone you're holding, there's a screen that you're watching right now. The fiber optic that is transporting this live data, this live feed to you right now. That's how glass, man. So there's some really cool inventions in the book. I highly recommend, and yeah, it's awesome.
That is
amazing. I thought glass is one of the inventions, but I guess I'm glad that you didn't tease, I guess, or spoil the 6 inventions. So now I'm like actually curious. So
yeah, no, that is awesome. Thank you, Yuri. So you've answered a bunch of great questions already. And we've talked about a bunch of great examples. One thing that we always like to do is to have our guests predict the future. So what do you think the future of edge or IIoT or cloud or manufacturing, what does all of that look like?
Oh man, yeah, that is hard to predict. But I can give you my personal opinion on where I think some of this some of the sides of the technology is going to go. If I think about edge devices, I just see them getting more accessible and more powerful for less money. It's just, we're going to be able to do more things at the edge, such as a few years ago we were not doing CV anomaly detection that has been around forever. But you couldn't do that in the industrial facility with an edge device because that wasn't such a thing, right? Now you can get a edge device that is the size of my hand with an NVIDIA chip on it that can do graphic processing, and that is, by the way, in the industrial enclosure. You can put in you can hook up to your industrial machine, right? So I think we're gonna have more and more options for edge devices, like microcontrollers that have more processing capability that can do actually machine learning and anomaly detection at the edge. And we are seeing some of those options rising on the horizon. So I think the edge is going to get more powerful, and it's going to get easier to developers to actually use those devices. So because everything is going to work really well together. So that's where I see the edge. Now, when I think of IoT in general, and how devices connected to the cloud. I think the future is we're gonna have so many connectivity options, from satellite to 5G and LoRaWAN and NB, IoT, and all those the spectrums of frequencies in between them, that I think the connectivity challenge is going to be finally defeated. I see that as a positive. I think we are not too many years away from defeating the connectivity challenge. I think the globe is going to be finally 100% covered in connectivity, and it's going to be easy to connect devices to anywhere. So I think we close to that with looking at what companies are doing out there.
That is a bold prediction, Yuri. For a person who is very worried about making a prediction of the future, that is a bold prediction of the future.
Yeah, I don't want to say too far or too close, but I think within the next 10 years, I think the connectivity challenge is going to be, the connectivity dragon is going to be tamed. We close, I guess.
No, that is amazing. That is amazing. Thank you so much. So we like to ask kind of the same last couple of questions to everyone. We'd love some career advice, right? So you talked about your career, right? I think it's a very interesting career, and you started, I think you said, in locomotives, and now you're helping to deliver and deploy artificial intelligence and machine learning at the cloud level, right? So you've come kind of about as far as you can go in parallel opposites. So what's some career advice, maybe to some mid-career folks looking to get into manufacturing? Maybe they're looking to get into edge or cloud services. What would be your advice to them?
Yeah, so I think my advice, if I can summarize that in 2 words, is be a specialist. It doesn't matter what you're doing it, if it's within manufacturing, if it's with connected devices, IoT, or just controls engineering, or just cloud or networks, whatever it is that you're doing, cybersecurity, I think what the industry needs today are specialists. Like, be very focused on one thing, have a narrow bucket, but go really deep into it. And that's what companies are gonna value, is, aim for being an authority on your subject. And I think that is what's gonna set you apart from the crowds, and will give you a nice career and probably a really cool job. And when you do that, make sure you pick something that you really like. Don't go for what you think makes money. Go for what you enjoy doing it. I do IoT because I love it. I don't think I can do anything else. So yeah, that's my advice. Be specialist. Being a jack of all trades, it helps you a lot, and you can be a jack of all trades. But once you accomplish that, pick one of those trades and dive deep.
I love that. I think that's good advice. Pick something you like and specialize in it. And if you have nearly as much fun as Yuri does as a career, you will absolutely be lucky. That's fantastic. Thank you so much. So last question for you, Yuri, is who should reach out? Who do you want to connect with? What type of conversations are you looking to have? Where can people find you?
Sure. I want to mention also, Yuri, on that question, we do have a few people asking technical questions on the YouTube channel specifically, and I kind of refer them to you as well. So hopefully there's a way to reach you, or like an IoT specialist from AWS in general.
Yeah. So anybody can reach out to me on LinkedIn with questions. That's all good. I'll point you to the right channels. If you have AWS specific questions, you always can go to aws.com, and we have it doesn't matter who you are. If you have an AWS account, even though you're not using or paying anything, you're using the free tier, you can jump on the blogs and channels and ask questions anytime. But by all means, feel free to reach out to me on my LinkedIn. And if you are a company or a IoT developer trying to solve a complex challenge in IoT and you think AWS can help you out, yeah, reach out. Also, I can't help but say that we are looking for talent. So if you're interested on working for AWS, go to Amazon jobs.com and filter by Amazon Web Services, and maybe put an IoT tag on that. And you can just do IoT and look at the open positions. And if you see anything that fits your profile and you like and interested, please reach out to me on LinkedIn, and I can tell you the next steps that you can take.
Awesome. Really happy to hear that.
That's awesome.
Cool.
I haven't been in some conversation as I think we have some questions in all, both super technical and less than super technical, that there's absolutely no way we'll be able to get to all of them. We will absolutely direct Yuri to those, and Vlad and I, of course, will be in the chat to go answer any further questions. But with that, this has been amazing. Thank you, everyone, for being here. If you are listening on podcast or watching on Solus PLC or LinkedIn, hit the thumbs up button, hit the subscribe button, rate us 5 stars on all of your Apple and other podcast platforms. That helps everything. As I like to say, we could tell you why it helps the algorithm, but that is not this show. In fact, Yuri is probably the correct person who has built the algorithm to tell us why it wouldn't help. But that is, maybe we'll get into that the next time we get him to come on to one of these shows. But no, thank you, everyone. Thank you to Siemens for sponsoring September and the Edge ecosystem. And until next week, we'll see you all soon. Thank you.
Thank you, Yuri.
Bye-bye.
Thank you, everyone.